Are you ready? My name is Barbara Cottrell, and I'd like to welcome you all here this afternoon. I'm the Seniors College Coordinator of the Public Presentation Series. And if anybody has any burning issues that you'd like to see us present, please come and talk to me. I'd love to hear from you. I'll begin by acknowledging that we're on the ancestral and unceded territory of the Mi'kmaq people, and we reaffirm our joint commitment to the treaties. Before I introduce our speaker today, I would like to ask you all a big favor. SCANS is now on Instagram and Facebook, and it helps our algorithm. I sound like I know what I'm talking about. If you go on our pages on Facebook, it's The Scans, THE, thescans.org. And on Instagram, it's Scans Social. And if you click, and especially if you share, that is a tremendous help to us. We're a volunteer organization. We run solely on memberships, and so we're anxious to get the word out about SCANS. So you'd be helping us tremendously if you would do that. There are some courses still running, and some of them are on Zoom. So if you want to join courses, especially ones on Zoom, you still have the chance to do that, and you can get all the back issues. So please feel free to look at the website and check what courses there are. I'm taking 2, and both of them are tremendous. Now I'd like to introduce our speaker today, although I don't think you actually need any introduction. Jim has been a weatherman now for many decades, and he is, I'm going to read this because I know I'll get it wrong, a fellow and past president of the Canadian Meteorological and Oceanographic Society. I think that he has contributed widely to the help of, to give Canadians help in understanding weather issues, and has received numerous awards for doing this. So without any further ado, I'm going to introduce Jim Abrahams, and he's going to talk to us about weather in Nova Scotia. Thank you, Jim.
Thank you very much, Barbara. And it's nice to be back here in SCANS. I did a little course on weather, I don't know, 3 years ago, during the pandemic. And it was in a little room somewhere else 3 years ago, and there was like 4 of us, and we were all socially distanced. So it's a pleasure to be with folks in the room. I retired from the Weather Service, Environment Canada, about 10 years ago. And most of what I did was around extreme weather. So I was a severe weather meteorologist in Montreal studying summer storms, and then came to Halifax to study winter storms. And then I was asked to help start the Canadian Hurricane Center back in 1989. And that was an amazing, I was the first Canadian to attend the Hurricane Center training in Miami. And shortly after that, I received some research funding to actually fly into storms. And we flew into Hurricane Juan in 2003, although the pilots told me to stay on the ground because they were a little nervous about the storm, and they wanted my advice where they could land. But I told them they could land in Sydney, but they landed in Stephenville. So I'm going to talk, when I retired, folks started asking me to talk about climate. Although I'm a meteorologist, I was a little hesitant to start talking about climate. But most of what we're seeing, and I was talking about what might be happening or what will be happening 10 or 12 years ago when I started these chats, now I'm talking about what is happening. And most of what is happening, although it's a changing climate, is in the weather patterns. And the extreme weather is a lot of what we're actually witnessing ourselves. The other thing is, although it's rather doom and gloom somewhat, it's a challenging topic, I do hope that I give some hope to you all that we will solve this challenge. We've been in a lot of bad spots as the human race over the since the start of the human race with wars and plagues and the like, and we've always managed to work our way out of this. So as a grandfather, I'm hopeful that we're going to work our way out of this one as well. So the story, the way I'll tell the story, at least try to tell the story, is a start on the simple, it's really not a complicated rationale on the story around greenhouse gases and climate change. It is serious and becoming even more serious. And as I said, we can actually work our way out of this and solve this challenge. So sometimes you hear skeptics say, well, the climate has changed before. And this is really a part of the natural changes that we've seen. And certainly the climate has changed before. This is 500 million years before present. And the climate was considerably warmer 400 or 500 million years ago. But it was really driven by a lot of carbon dioxide through geological, tectonic, and volcanic processes. There were no human beings through this period, varying carbon dioxide and varying temperature, until at the very end here, we showed up. And the CO2 concentration, that's the amount of times of present value, had finally settled down to the present but changing concentration of CO2. The other thing I'll say is that these changes take place over millions of years. And the changes that we're seeing now have taken place over our lifetimes. And that's incredible to think of how rapid the changes are taking place. The other, perhaps shorter variation in the climate is due to subtle changes in the orbit of the Earth around the sun. And the primary cycle is the glacial cycle. So there's ice ages, if you want to refer to it, in relative continuous or intermittent kind of cycles in the tens of thousands of years. And they kind of start, in fact, I remember when I was a kid, they were saying, well, you know, we're going to be heading into an ice age. And if you look at the curve, typically we might, but of course, entering into an ice age is a 10,000 or 26,000 or 41,000 year process. It's not going to take place in my lifetime, but it was a conversation, of course, when I was a youngster. But it starts when the orbital cycle changes enough that the summers are cool and the winters warm up enough so that there's more snow than normal. So it's not like it's raining, it's snowing, especially in the north, and the snow piles up. And then because the summers are cool, it doesn't melt or only partially melts. And over time, tens of thousands of years, this actually builds up the snowpack and it expands through a feedback process. Basically the glaciers move south far enough to our latitudes to actually change the climate. And the other thing is that the CO2 actually goes down. The carbon dioxide also goes down as well. First of all, the ice itself stores a lot of carbon dioxide. So a lot of it is stored in the ice. And the grinding ice and the lower sea level, so the seas have lowered because of the amount of ice. There's actually more vegetation around, and the vegetation absorbs carbon dioxide. And so the carbon dioxide actually goes down as well with these ice age cycles. And you can see here, this is 800,000 years of cycles. The red is temperature. So from the cool cycle to the warm cycle is about 10 degrees difference. These are from ice cores in the Antarctic. So the temperatures are actually Antarctic temperatures, not global temperatures. But the carbon dioxide levels in the atmosphere are in blue, and they range from bottom end 200 parts per million to the top end just below 300 parts per million. So 100 years ago here on Earth, we were at about 280 parts per million. And you see these cycles, as I say, take, I guess around here, humans, kind of the species as we know it, started showing up in Africa during one of these actually ice age cycles at the bottom end of it. But over the next 10 or 20,000 years, as the Earth warmed and the glaciers retreated, there was actually movement of the population into Europe, where it became more habitable with a warming climate. What's interesting now, which is rather alarming, of course, as I said, it takes, say, 10,000 years to go from the bottom to the top of carbon dioxide. Well, we're now up here at 423 parts per million, and most of that has taken place in our lifetimes. And that's remarkable when you think of the changes and the speed of the change of carbon dioxide in our atmosphere. So essentially the story, as I said, is rather simple. You burn fossil fuels. The fossil fuel burning process releases a number of chemicals, but carbon dioxide being the more critical and predominant greenhouse gas. And with more carbon dioxide in the atmosphere, the temperature rises. So the atmosphere is mostly nitrogen and oxygen. Luckily, there's lots of oxygen. But we are actually quite fortunate, even though the amount of greenhouse gases is rather small relatively, it's really important. And carbon dioxide being one of them, and that's the one that's changing most substantially with since the Industrial Revolution. Methane is to some degree as well, and nitrous oxide, which is another pollutant, is more like one of the contributors to smog, is increasing. But carbon dioxide, the challenge with carbon dioxide, it lasts hundreds of years. So the carbon that was burned and released into the atmosphere, the carbon dioxide when we were born, is still there. And so we're piling it up. So the greenhouse effect is actually really important for our survival. So the sun reaches the earth. The atmosphere, other than some pollutants and clouds, is mostly clear, and the sunlight reaches the earth. Some of it is reflected back, and some of it is absorbed onto the surface of the earth. But a good portion of it is actually re-radiated, comes in as ultraviolet radiation and is re-radiated as infrared radiation. And fortunately, most of that re-radiated heat is absorbed by those trace greenhouse gases, including carbon dioxide, and is re-radiated in all directions, and it keeps us warm. It's kind of like a blanket. And that blanket keeps the average temperature of the Earth at about plus 15. Certainly it's not plus 15 here, but if you average it between the tropics and the north in the winter and the summer, it's about 15 degrees Celsius on average, which is quite habitable for us humans. Without carbon dioxide, or the greenhouse gases in the atmosphere, that heat would re-radiate into space, and the average temperature of the Earth would be about minus 15. And so without that blanket, it would be too cold to survive. So that teeny bit, 300 parts per million, now 423 parts per million, it's quite small amount, but it's extremely important for the survival. The challenge we're facing is that blanket, which, as I said, 100 years ago was 280, maybe 300 parts per million, is now 420 or 423. It's 50% thicker than it was prior to the Industrial Revolution, and consequently, that blanket's keeping us warmer and allowing the atmosphere to, or the earth to continue to warm. So this is not a new science. Actually, any mathematicians in the room would know that Fourier was a remarkable mathematician, but he had figured out that CO2, carbon dioxide, had these greenhouse gas properties. And a female scientist, Eunice Foote, continued some of the work started by Fourier. Arrhenius, he's a Swedish scientist, continued advancing some of that work. And then actually a fellow, a British scientist, Calendar, he actually started the concern around what the burning of fossil fuels was going to actually do to our climate. So the Industrial Revolution all started in 1776. It sounds like an interesting date. We might as well start with a date that everybody remembers, 1776. And James Watt was one of the fellows who kind of refined the steam engine. And those of you who think about energy today, it's mostly measured in watts. And certainly our electricity, what we pay to Nova Scotia Power, is in kilowatts or kilowatt hours. And so he's certainly been memorialized by the work he did with energy. Now, this steam engine and what followed from the steam engine has had remarkable impacts on society. It has enabled rapid advances in transportation, so trains and ships and automobiles and aircraft. But really, the discovery of this energy has mobilized and enabled more efficient food production. No more oxen and horse. They could use tractors and other equipment to harvest. And not only that, the cities grew quite quickly, and cities could not grow quickly unless you could move food and clean water and treat the water that's in the city quite efficiently. And you could only do that through energy, is move the food in, supply the food, store the food so that it didn't go bad. And this really enabled cities to start growing in the 1800s and the early 1900s. And then electricity. Electricity really advanced our science and technology. Healthcare systems advanced, computing technology advanced, it reduced infant mortality, it reduced heart disease. Our communication, look at the communication we have now, and I won't pull my phone out of my pocket, but it's a changed world, enabled essentially by energy. And it's all fueled essentially, well, at least over most of the last 100 years or 100 or 200 years, by coal, oil, and gas. And it's the burning of these fuels, these fossil fuels, that releases the carbon dioxide in the atmosphere. And as I said, it lasts for a long time, so it doesn't go away. Now, if we think that first humans showed up, let's say 100,000 years ago, where the Neanderthals are a variation of our species, it took a long time, 100,000 years, say, for the population to finally reach 1 billion. And then, as I said, science and technology and advanced, the Industrial Revolution, which started around then, enabled the population, especially the population in the cities, to grow remarkably quickly. And in only, what's that, 120 odd years, it doubled to 2 billion. And then 1960, when we were all around, 3 billion. And then it accelerated exponentially to this year at 8 billion people. And most of these 8 billion people, like you and I and many others, we rely on this energy as part of our life, our transportation, our heating, the food we benefit from. And consequently, the growth in greenhouse gases is correspondingly increased, as well as the release of carbon dioxide with the increase in population. And so, indeed, the carbon dioxide, which is in yellow or kind of a greenish yellow here, increased to 280 at year 1880 to currently in 2024, it's about 423 parts per million. So quite an exponential increase. And the temperature, although it doesn't seem remarkable, it has also gone up pretty well following the same trend and accelerating. And it's now very close to that 1.5 degree Celsius temperature where scientists are particularly concerned will have a very detrimental impact on our climate. So if you just look at these two curves, they're not coincidentally alike. So the outcome of the growth in population, the growth of greenhouse gases, and the concentration of carbon dioxide in the atmosphere, although it's rather simple relationship, it's rather serious, as I said, and becoming even more serious. And what's interesting, and I remember when I retired, the first group that asked me to do a talk, and I started out with the warming temperatures, it was a bunch of golfers actually at Ashburn. And like, warming temperatures, like, bring it on. Like, what's the problem? And that certainly for us Canadians, it's natural for us to say, bring it on. We want more warm temperatures. But it's the consequences of those warm temperatures in an atmosphere that's very balanced. There's a water cycle and an energy cycle and a carbon cycle. Our ecosystems, everything is extremely balanced. And when you change that balance, even it doesn't seem by much, by 1 or 2 degrees Celsius, it actually has extreme consequences on our life and on our weather and certainly on our oceans. So last year was the warmest year on record. In fact, the last 10 years were the 10 warmest years on record since 1880, since we started keeping weather records on Earth. So this is actually pretty remarkable, if not somewhat scary. And in fact, what's particularly, and scientists are still trying to figure out this jump in 2023. You see, there's a few jumps here and there in the years 2019, 20 back to 16. But then there's a jump, a considerable jump last year. And some scientists are attributing it to El Nino. Last year was an El Nino year where there was a lot of warm ocean water off the west coast of South America, Central America. And perhaps was El Nino contributing to that additional warmth. But they really don't know. But, and then if you look at us, Peter Lewis, my colleague at the Canadian Meteorological and Oceanographic Society, he does a monthly summary of what the weather was like in Nova Scotia over the past 30 days. And he's been doing this for almost 3 years, just a little over 3 years. And when he saw that I was going to give this little talk, he said, Jim, I hadn't noticed this before, but at the Halifax airport, the average temperature over the last 3 years, it's hardly ever been below, these are monthly average temperatures, hardly ever been below normal. And when they were below normal, they're only slightly below normal. And in fact, the average over that period, and I didn't calculate it, but it's pretty close to 2 degrees above normal. And that's pretty remarkable, actually. So although we complain about the weather, it has been actually much warmer than normal. And it's the folks in the tropics that are facing the consequences of this at this point in time much worse than we are, because their society cannot handle that heat. They don't have certainly the infrastructure for cooling that we do. They certainly have challenges with water resources and big problems with food security. And so people are dying actually quite substantially in tropical nations because of lack of food, lack of water, and because of the heat. And right now, I mean, I don't know how many of you read the UK online Guardian, but there's usually climate stories. Well, in fact, usually there's always climate stories. In fact, all the newspapers, you don't have to go very deep to find a climate or a weather story. And the stories right now is both the heat in the Philippines and the heat in Western Africa, Chad, and the like. But you don't have to go very far to find the floods in Eastern Africa and recently in China. And each of these are killer events. And Brazil, killer floods in Brazil this week. Brian McNulty is a hurricane meteorologist in Florida. I think he's at the University of Florida. Anyways, not long ago, he put this on Twitter, and it's basically a series of the average temperatures in the North Atlantic through the last 23 years or 43 years, 1981 to 2024. And so there's a cluster around average here, up and down. But last year, starting around this time of year, the average temperature in the North Atlantic, so this is where our hurricanes are born, jumped and stayed substantially above normal. In fact, records warmth. In fact, it's 400 consecutive days where the Atlantic sea surface temperatures are breaking records every single day. And I don't necessarily have a reason for this. Certainly climate change is contributing to it, but why it's jumping. In fact, the start of this year has jumped even more. And so this is alarming, certainly to Brian and other scientists. And he's a hurricane forecaster. And so he's concerned, obviously, about the change in the hurricane threat. And of course, most people, in fact, in the world live along the coast, are concerned about the potential impact on the sea level rise. The same kind of trend, but not as dramatic, on ice, whether it be sea ice in the Arctic, even around the Antarctic, and land-based ice, whether it be glaciers or ice sheets, are actually trending in the same direction, less and less ice. So it's melting, and that melted ice, not so much the sea ice, but the land-based ice actually contributes to the rising sea levels. And as the oceans warm, and as the glaciers and ice sheets melt, the sea levels are rising. This is an article that was in the Washington Post this weekend, actually. Abnormal and unprecedented surge in the sea level rise is imperiling the American South. So from Texas to North Carolina. My cousin and I, on his 65th birthday a few years ago, we were sharing a couple of drinks of scotch and talking about my favorite, not my favorite topic, but the weather and the climate. And he was somewhat skeptical about the seas rising enough to flood Miami. So we have a wager that when he turns 80, so that's 11 years, 12 years from now, when he turns 80, Miami will be flooded. That's what I said. he said, no way. So there'll be a bottle of scotch passed one way or the other when we turn 80, whether or not Miami is flooded or not, or half flooded. The definition of flooded is going to be, of course, challenged. And of course, here in Nova Scotia, if you look at the numbers in some of the maps that the province has put out, we have to prepare for a meter. But there's uncertainty even in that meter. And of course, on top of the meter, there's storm surge when we get a big storm and waves on top of that. And I was on the Rick Howe show one time, which is something else. God bless Rick. And so, of course, I was brave or foolish enough to take calls from the listening audience. But there was this call, and kind of a sad call from a lady who was purchasing property in Prospect. And she said, Jim, I don't have a clue whether that house is going to be flooded or not. And this is a substantial investment. And of course, part of the problem is, of course, we don't have the kind of detailed flood maps. Certainly a few years ago when I was on the Rick Howe show, we had nothing. And I was trying to console her a bit, but I had to give her some advice. And I said, well, go find out from the tide tables where the highest high tide is in the course of, a decade. And then add a meter to that. Then add a meter and a half to that for Hurricane Juan, and then add another meter for a big wave. And I said, if that goes up your front step, I wouldn't buy the house. And then I turned and looked at Rick and I said, it shouldn't be Jim Abraham, the weather guy, telling someone on Rick Howe whether or not to buy a house and where to buy it. Something's wrong with the system. But like any good weatherman, you give somebody an answer when they call. I remember when we used to answer the phone in the weather office, people used to call for the lottery numbers. That's because we answered the phone. And all kinds of astronomical questions we got asked. So we had the what's it called? The observatory, forget it now, the book, with all the almanac, not the farmer's almanac now. We wouldn't have that in the weather office. But we had the astronomical almanac so we could pass on astronomical questions on the phases of the moon or on asteroids or what have you. So what's that? The Observer's Guide. Thank you. So it's not the averages necessarily that's causing us a challenge. It's actually the extremes. And this simple graph, let's say it's temperature, and normally in blue, the temperature is kind of a normal distribution around the average temperature. So let's say our average is 5. And once in a while, we get 30, not very often. And once in a while, we get minus 30, not very often. And then you shift the average by 2 degrees, which is what we've already shifted it by. The actual extremes in the one standard deviation extremes changes to such that what might have been a 1 in 40 year event in this little tail of the distribution to a 1 in 6 year event. And so what was unlikely is becoming certainly substantially more likely. And so it's a question of risk management. And so we're all living now in how we're going to manage that increasing risk, whether it be temperature, whether it be sea level rise, whether it be storms and floods and the like. The risks are actually going up. And the other thing that's happening, and it's not been proven, but it's certainly been observed, is that the Arctic is warming because of the change in albedo. So as the ice and snow disappears, the Earth absorbs more of the sunshine in the north. And so it's warming up 3 times faster, actually, than the rest of the Earth. So the Arctic is warming up quite quickly. And the tropics are not warming up nearly as fast as the north. And the jet stream is really a function of the change in temperature between the Arctic and the tropics. So in the wintertime, the jet stream is quite strong because there's quite a remarkable difference in temperature between the really cold Arctic and the tropics, where people tend to move and visit in the wintertime. But in the summertime, the difference in temperature is much weaker. And as the Earth warms, this difference is weakening. And so there's some discussion on whether that's having an impact on the jet stream, the strength of the jet stream. And like a river, if the stream is actually weakening, then it will become more meandering and moving slowly, more slowly. And so there's some discussion, it's not proven yet, but it's certainly been observed, that the jet stream is more wavy and moves considerably slower. As well, it kind of stays where, because it's moving slower, it stays in the same place for periods of time. So if you think of us last year, we started off with a dry spring. It was a mild spring, and then it got hot in May, late May. And then, of course, I was in Newfoundland at a Canadian Meteorological and Oceanographic Society meeting. It was 6 degrees and drizzle there, but it was 33 degrees and fire here in Halifax and other parts of certainly southwestern Nova Scotia. And so we were in this kind of warm pattern, dry pattern, for a period that started several months earlier. And then it ended rather abruptly, and we were all happy that it went from a hot, dry pattern to a cool, damp pattern. Everybody was happy for the firefighters, for the residents, except the golfers. It stayed wet for 2 months or more. In fact, that period of cool wetness ended with those extreme floods. Often the end of those periods of kind of stationary weather end with an extreme event, and then the pattern shifts. And so the 33 degrees and fire shifted quite quickly to the cool, and then the cool and damp, and then the cool and damp peaked in late July and early August with a couple of substantial, in fact, historic flooding events. And then the latter part of August and certainly into the fall was pretty normal. But this is a potential contribution to our extremes. And the other thing is, when storms do go pass in our area, there's a risk that they may be moving more slowly. And certainly Dorian and Fiona moved much more slowly than Juan. And consequently, the impacts were considerably more remarkable. So the impacts are on the extreme side, on the heat and drought. And few people, some of you may realize, but actually the largest loss of life in the history of Canada from a weather event was only 3 years ago. And it was the heat dome in Vancouver. 224 people lost their lives. And so the heat, even in this part of the world, is actually of concern. In fact, I read an article today where it's not the real extreme heat where people know to take refuge. It's the kind of real hot weather, like 30 to 35, where you do more than you should. You're not sleeping well at night, and it's not cooling off. That actually impacts people's health more than the extremes. So you end up with the heat and drought side, water shortage. Wildfire also comes with smoke. And in fact, there's a substantial impact on the air quality and the impact on breathing problems, especially in the western part of North America. And of course, it affects our farmers. The opposite, the floods, of course, people unfortunately are dying in floods. And unfortunately, here in those flash floods killed 4 here in Nova Scotia, impacting infrastructure. So certainly anything in the coastal zone, as well as the coastal erosion as far as sea level goes, and then tearing transportation infrastructure, what it does to the highways when you get those flash floods is amazing. The biggest loss in the insurance industry in this country is from wet basements. So our insurance is going up. Most of it is because of flooding in our basements. Not only that, it's the stuff we put in our basements. My grandmother had coal and preserves in her basement. She had some root beer she made for us kids. Now, people have entertainment systems and spare rooms and all kinds of stuff in their basements. And of course, the basements aren't any less likely to flood, perhaps more likely. Hurricanes, something we need to prepare for. And then the winter question, I've done three talks to the farmers recently, because the farmers are scratching their head, what's going on in the winter? We're getting these cold events and they're having a big impact on crops. And part of it is not necessarily the frequency of the cold, is that it's surrounded by above normal temperatures. So you have, December and January, and the plants are, oh, this is an easy winter, we're doing good. And then bang, -30. And the plants are not hardy enough for that, neither are we. And it actually, we lost a good portion of the grape crop last year with one of those events. So for the last 10 years, I've been, well, actually, since I started the Hurricane Center, I've been involved with the insurance industry. Because when I started talking about hurricanes in Canada, first the Americans started scratching their head why this Canadian is at this course. And because, it wasn't, we had some big ones, but not very frequently. But the insurance industry was very interested. And I went to a number of meetings with the insurance industry to talk about the increasing risk from tropical cyclones. Well, the insurance industry gets it, because what the insurance industry globally is the costs, the number of billion-dollar events are going up quite quickly. Part of it is because of the stuff we have. Not only our basement, I can't even park my car in my garage because it's full of stuff. So we have stuff that's worth more, and when there's an event, of course, the loss is bigger, but there are more events. And so I go to this conference every year. It's a conference on catastrophes in Toronto. And because I'm not an insurance person, I'm kind of a neutral person in the crowd, they actually asked me to be the MC. And so most of the folks are insurance folks. And they start off the meeting every year summarizing the industry, what's going on. And one of the first slides is always this slide, the number of catastrophes in the last 40 or some years, and the cost of those catastrophes in time. And the trend is certainly upwards. 22 and 23 weren't here, but the 3.1 billion in 22 and 23. So it's continuing to trend upwards. This is the ice storm in 98. This is the big floods in Calgary and Toronto in 2013. And this, I forgot to bring the book on fire weather. It's a great book on, and I'd recommend it to any of you, and it's available in the libraries here. Fire weather. This is Fort McMurray. And the interesting thing about the book on fire weather, Fort McMurray, like the hub of oil sands development in this country, and nobody would have imagined to have that city burn down from a wildfire and have that fire jump 1 kilometer across the Athabasca River. Then the second part of the talk is going over the catastrophes from the previous year. So Nova Scotia came out disproportionately impacted by storms, by events last year in the insurance industry. And Laura, who's the CEO of Cat IQ, she says, Jim, she says, you've got to be there. We want you to talk about what happened to Nova Scotia. And in fact, the last session in the first day was a fireside chat between Jim and Mike Savage about what's it like to be mayor following the Fiona in 2022 and then the events in 2023. Of course, Mike couldn't get up to Toronto because of the snowstorm in February, the big snowstorm. I remember that big, it was 150 centimeters in Cape Breton, but you know, it was what, 50 or 60 or something here, maybe 70. I'll talk about what Mike said in a minute, but I'll just go over some of these events. This is this cold snap that killed all the vines in the Annapolis Valley and elsewhere, but it also burst a lot of pipes and ended up causing substantial, it was a catastrophe. So it was certainly over, I think catastrophe is over 50 million in this part of the world, certainly in Nova Scotia. There was records broken. I have a slide about that. Then the wildfires, then those big flooding events. This is the Sackville River through Bedford here. This is a substantial loss in insurance loss, but not only insurance loss. There's a lot of homeowners that did not have water coverage and lost. They're still challenged with getting government assistance for those flooding losses, especially in Bedford, but certainly elsewhere. There was another flooding event that a lot of basements flooded in Halifax in the middle of August. Post-tropical storm Lee, it affected mostly Western Nova Scotia. Luckily, we had some power outages here, but it wasn't catastrophic. And this one I don't even remember. There were so many storms, and this was in the fall. There was a big wind and rainstorm that caused a lot of roof damage, power outages. It's either late November or early December. It was such a stormy year. And so I was talking to Mike like I'm talking to you folks on this in the hybrid world. And Mike was up on the big screen, and there's big screens behind me with Mike in his office. And I, you know, he's pretty chatty, and talked to him about what it's like and the challenges. He talked about the investments the city was making in the Halifax program. So making the city more resilient, but also investing in reduction in fossil fuels through active transportation, buses, and just a number of strategies to reduce the carbon footprint for the city of Halifax. And somebody asked Mike, you know, what's the impact on the taxes in the city of Halifax from that program? And Mike said, oh, don't worry, I'm hearing about it. And they said, so what do you say to people? He says, look out the window. Because you know, like, let's face it, all you had to do was look out the window, unfortunately, last year. So the extremes, I talked about using the case of temperature, but the precipitation extremes are going up because a warm atmosphere holds more moisture. And when you squeeze that moisture out of the atmosphere, you end up with higher amounts, considerably higher amounts when you squeeze every drop out. And so a study out of the UK basically concluded that big thunderstorm, kind of the 20 or 25 an inch an hour or more flash flooding like we had last year, is going to be 4 times more frequent in 50 years from now. And these are just guesses. My observation, I did a study for the city of Sydney or CBRM and HRM, I don't know, about 6 years ago, and they asked me about return periods on precipitation. And, you know, the 100-year flood, so the likelihood being 1%, the 1% flood was like 120 millimeters in 24 hours. And I said, prepare for 250, which was Hurricane Beth in 71. And 250 is what we got with that event last year. So whatever you might think, it's turning out sometimes to be even worse. So this was a tragic event. I was on the news a lot about that event because one of the things, unfortunately, we don't have a flash flood warning program in Canada because flooding is the jurisdiction of the provinces. And provinces like Nova Scotia don't have the capacity to do flood warnings, and no province in this country has the capacity to do flash flood warnings because they're very short term. You have to have a 24/7 operation. And consequently, because of this jurisdictional issue, we do not have flash flood warnings. And it's the floods in the USA that kill more people than any other event, including hurricanes. And it's the flash floods with the hurricanes that cause more deaths with hurricanes. And I mean, they provide some really good advice in the States, like shelter in place. And, you know, people see water coming towards their house, they want to get out. My house is going to float away. But your house is much likely to float away than your car or your bike or your personage walking. And so in the States, they say, stay, shelter in place, go up, don't go out. And they have detailed flood maps so that folks know which homes are at risk, so EMO can actually target those homes. And we don't have that here in this country, for that matter. This is the total rainfall and lightning. Lightning here, remarkable lightning. I've never seen lightning reports like that. And this is a swath of 150 to 250 millimeters of rain from the South Shore all the way up into Middle Musquodoboit. Incredible rainfall, tragic. Fires, last year was the worst year in the history of Canada in wildfires, and certainly in Nova Scotia. And extreme weather makes Canadian homes harder and more expensive to insure. So the insurance industry is really concerned about this as well. And hurricanes, we don't know if there'll be more hurricanes, but the impacts are likely to be worse because the storm with warmer seas, the storms would be more intense because that's the fuel of the storms. The sea levels are higher, so when they come on shore, the storm surges are worse. There's more moisture in the atmosphere, so the rainfall is heavier and more likely to have flash flooding. And as I said, maybe the storms are moving more slowly, so there's higher impacts. And certainly Dorian was the record-breaking power outage for Nova Scotia Power. You know, they get picked on, but you know, we do lose our power a lot, and Dorian was a record. And then, of course, Fiona, just 3 years later, was a record-breaking storm. $3.09 billion in damage, the costliest tropical cyclone in Canadian history, the lowest pressure in Canadian history, broke all kinds of records. Tragic. People are still not recovered from Hurricane Fiona in Prince Edward Island, parts of the North Shore, and even parts of Cape Breton. And then there's the cold risk that I talked about, whether or not these wavy patterns bring down the cold air from the polar vortex and break the polar vortex enough to enable the cold air to come down. It's still not known, but we are seeing it enough to make it concerning. And so while the future winter will still be variable, as I said, sudden extreme cold events during a milder stretch can have a big impact on sensitive plants and trees. And then heavy wet snow and rain and ice and snow on top of it. So if you get more precipitation in the form of snow, certainly has an impact on our infrastructure. And this is the global temperature map for 2015. Don't know if anyone remembers 2015. I certainly do. The whole world was above normal, except this part of the country. You can kind of see this wave here where Eastern North America was well below normal. The blue is well below normal. And that was our famous winter of 2015. Lots of collapsed roofs. Our sidewalks weren't cleared for 6 or 7 weeks. I've asked the insurance industry for a number on this event. And because it wasn't a single event, it was an ongoing event over a period of time. They don't have one number on it, but it certainly was extreme. And this is the record cold event in February of 2023, records broken all over the Maritimes. And that had a significant impact, as I said, on frozen pipes and burst pipes, but also on the agricultural community. And the impact of these events locally and globally, I mean, this is India and Spain. The farmers are marching because of the impact on their business, and they're losing money. And we need farmers, and it's tough. And the costs to us, because these costs are being passed on to us, insurance system is under strain. My insurance has gone up a lot in the last 10 years. Nova Scotia Power is looking for some money because they've had significant impact, both in 2022 with Fiona and again in 2023, millions of dollars that they want to pass on to us because there's no source of funding. There's no imaginary source to give to allow them to recover from that. And then there's other kind of tipping points that you'll hear talked about, feedbacks in the climate system that are not necessarily well understood, and the timing and the strength of them hard to tell. But the tipping points, and I'll give you a couple of examples, could result in abrupt transitions. And you read a little bit about them. Ice, for example, I kind of alluded to the fact that when the ice melts, the soil and the sea is darker, so it absorbs more heat, which melts more ice, and it's kind of a positive feedback. If that goes faster than expected, then Greenland and Antarctic ice sheets could collapse or melt quicker than expected. Permafrost in the Arctic, when the permafrost melts, it releases methane, which is a really powerful greenhouse gas that warms the atmosphere even more, and of course that melts the permafrost even more, and you get this kind of runaway feedback, positive feedback. The one sometimes you may hear about the thermohaline circulation or the Gulf Stream. And so with all this melting ice in the Arctic and the fresh water, it actually reduces the density of the top of the sea. And normally the Gulf Stream and the warmer parts of the circulation from the tropics to the north, certainly northern Canada and Europe, it usually sinks when it gets up north and cools off, and because of changes in salinity and the like. Well, that circulation is slowing down because of all the fresh water which is sitting on top of the sea. And if that does happen, certainly there's going to be a negative impact on European climate, to some degree our climate, but further south the warm water kind of will pack up and it'll actually be warmer than normal. So it'll end up with a kind of a cold north and warm south if it does happen. But they've measured a weakening in this circulation, and someone came out and said it could collapse as early as 2025. I think that's a little alarmist, but it gives you the point that some of these quick things could happen and catch you by surprise. So I'll just summarize and then we'll have a little bit of a break. So the population is increasing exponentially, and it's been enabled by the growth in science and technology, the Industrial Revolution, and that really was enabled by the production or the use of fossil fuels, starting with the steam engine. That's releasing carbon dioxide and other greenhouse gases in the atmosphere. The planet is now the warmest it's ever been in humankind. And the impact, not only on average, but it's also the extremes. And that's threatening our health and safety, our food and water security, and it's costing us money. It's not only the carbon tax, there's all these other costs that are due to climate change. And then there's these uncertain, hopefully unlikely, but high impact tipping points. And this is 2015. That's my wife and my granddaughter out in front of their place. And we'll take a 10 or 15-minute break and have some goodies. Thanks. Okay, folks, hopefully this will be a little more optimistic on the solvable thing, but it's certainly still a challenge. So there's three approaches to kind of deal with this challenge. One of them, you sometimes hear the term mitigation. It's used in different ways, but the mitigation with respect to climate change is really reducing emissions. So often you'll hear net zero, we have to stop releasing carbon dioxide and other greenhouse gases into the atmosphere as soon as possible. Adaptation meaning we already see it. We're already dealing with the challenges of extremes and changing climate. So we need to adapt the way we live and enable our communities to be more resilient. So that's adaptation. And then there's the third, perhaps somewhat more controversial, and that's intervention. That's mucking around with the climate so that the climate will stop misbehaving. We're not going to stop misbehaving. The climate will stop misbehaving, and that's an intervention. And I'll give some examples of that. So mitigation, of course, this has been good. This conversation's been going on for a long time. Probably the most substantial international agreement was Kyoto. And it's amazing. I mean, 1997 is what, 25? Well, 27 years ago. And we really have only gotten worse, unfortunately. Then Copenhagen, then Paris is the one where there was some agreement, pretty good agreement, actually. We have to do something. They acknowledge that this is serious, and we've got to take it serious in order to limit it to 1.5, but often now you'll hear limited to less than 2, because the 1.5, that horse is almost out the barn. So the Paris agreement looked like people could get fooled. I mean, basically, you've got to reduce things by 2.7% a year, starting as soon as possible to get to 2 degrees, and 7.6% a year of emissions to get down to 1.5, or keep it from being 1.5. It went down, but it went down because our economy went down during the pandemic. And then as soon as the pandemic eased off, we're back on our current path. And the current path is not good. It continues to rise, but the commitments are still there, which is good. But the actions are somewhat slower than the commitments for a lot of reasons, many of them political. I heard someone say that, how did they word it? That politicians, the fossil fuel industry does a lot better job influencing politicians than reducing emissions. Anyways, we basically got to stop as soon as possible releasing carbon dioxide using fossil fuels to keep it in Canada to 2, because the Arctic things are moving faster. We could be as high as 7 above normal in Canada because of the Arctic amplification. And so we really need to reach net zero by 2050 as a noble and achievable commitment. So, there's a lot of finger pointing when it comes to this stuff internationally. And that, of course, China is increasing it's there in yellow, its emissions substantially faster than other nations. India is also increasing its emissions. And then we're actually slowly lowering our emissions in the European Union and Japan. Canada is about the same as Japan, that little maple leaf I got there. But overall, the amount of emissions is going up. But of course, the Chinese will say that our per capita emissions are much lower than the United States. And India will say even, we're still a developing country. We have to catch up. And it's not fair. And the European Union is probably the most responsible, but they're having challenges as well politically. And Canada is actually among the, if not the worst per capita. But of course, people say that's fine. We're a coal country, big distances and lots of transportation. But it really isn't fine, but it is what it is. But in Canada, per capita, so if you go back we were about 17 sorry. Okay, we were about 17 tons of carbon per person. But in Canada, most of the per capita emissions are from Alberta and Saskatchewan, where the oil and gas is being developed, the oil sands and natural gas. And so that's such an important part of their economy that they're not budging very quickly on that one. New Brunswick and Nova Scotia, we still have a lot of coal in our electricity generation. And so that's contributing to a higher amount of per capita than the other provinces. Quebec is the best off because they have such a substantial hydroelectric resource. We don't have much hydroelectricity. Our rivers are quite small, and we do get some from Newfoundland. Ontario has nuclear. You might argue one way or another about nuclear, but it gets the job done. It is fossil fuel emission free. And so between hydroelectric and nuclear, Ontario is actually in a reasonable position comparing the rest of the country. So here in Nova Scotia, most of our emissions on the bottom have been electricity, and that's because of coal. We still have, I think, 30, I have another slide here, but 30 some odd % of our electricity generation is by coal. And coal is pretty dirty when it comes to carbon dioxide. The next biggest is vehicles, transportation, cars and trucks and planes, but mostly cars and trucks. The top is industrial activity. It's gone down a bit, and I think maybe because of some of the either closures or efficiencies in the pulp and paper industry. But I can't say I'm sure of that, but it seems reasonable. There's agriculture, there's marine and air transportation, and then there's buildings, heating the buildings. And there's been some efficiencies there, but not large, but because of heat pumps, mostly. But if you look at the targets, our improvements have been largely on the electricity side, and that's because of the wind and solar and importing the Maritime Link hydro from Newfoundland. And the target for 2030, so I don't think we'll hit, I think they changed it maybe to 2035, but it's largely driven by a reduction in electricity. So it's the Nova Scotia Power Challenge, is to eliminate coal. And if you do the calculations, it's pretty tough to replace all of that coal with wind and solar. So I don't have the right answer to that, but that's the target. We will get some efficiencies from continuing to improve our heating, our buildings, but there's not a lot of action other than by on the heat pump side, and there's very little action provincially on transportation. So on electricity, as I said, there's 31% on coal. Natural gas is 17%, but the price of natural gas has gone up. And then wind has increased substantially. Hydro is going to be pretty fixed. Biomass is a controversial one, but we're getting a small percentage. Imported renewables, some from New Brunswick, mostly from the Maritime Link, I think. And then there are various other imports from New Brunswick, electricity that are not, they're not necessarily clean. So this is the big one that we have to deal with, is the coal. And when it comes to heating our homes, it's complicated. All these various heating sources, and I don't have time to go through them. One of the cheapest with the least greenhouse gas emissions, the cost is in blue and the greenhouse gas emissions are in green. I think that's assuming you plant a tree for every tree you cut. And that's kind of a loose assumption. The most expensive is a propane fireplace, if you're using that to heat your home. It's the most expensive. The worst as far as greenhouse gases is radiant heat in your floor. And baseboard is pretty bad too. It's expensive and a lot of greenhouse gases because of the coal. The best of them all, natural gas is not bad, but the best deal, in spite of the fact that we're using a lot of coal, is either heat pump using geothermal or mini split heat pump. They are the overall the cheapest, most efficient, and least greenhouse gases. And that's why the federal government, and particularly, but certainly provincial government, is supporting the transition to heat pumps. Even if you need a backup, the heat pump's good most of the time. Now I can speak to that. I still have to turn my furnace on once in a while, but I'm careful. So the achieving net zero, there's a lot of it is electricity, of course, especially if you're going to electrify our transportation network. So EVs, electric cars and trucks. So we need electricity for that. We need electricity for our heat pumps to heat our home, for heating and cooling. We need more cooling. I never thought we'd need air conditioners, but I mean, I didn't even have air conditioning in my car when I first bought a car, but now all the cars come with air conditioning, and most people are putting heat pumps. A lot of them are putting them in their homes for the cooling, not necessarily the heating. So wind and solar, hydroelectricity, which we don't have a lot of, but we can import it. Geothermal, which is being done by some who live near the shores, because the sea offers a geothermal opportunity. Biomass is a little controversial, not as controversial as nuclear. Storage, because the wind doesn't always blow and the sun doesn't always shine, you really do need storage batteries, a system to store the renewable energy. I have 20 kilowatts of battery in my garage to store my solar panel, and it's part of the Nova Scotia Power Smart Grid pilot that I'm lucky enough to get to benefit from. There are alternative sources of fuel, biofuels made from like corn or other kind of plant material or the like. Green hydrogen, which is you use renewable energy to create chemically hydrogen and ammonium using wind power, for example, which is the plan that I think, forget the name of the company, what's it called? Yeah, Everwind. Anyways, it's controversial because it's exporting most of it to Germany. We signed an agreement with Germany on that. And then, of course, we changed the way we manage our forests and our agriculture to minimize the release of carbon within the soil and maximize the amount of green space through agricultural cover and trees to actually absorb some of the carbon dioxide. Then there's intervention, as I alluded to. This is an article, CBC article, are we ready for the sunblock? And basically, a lot of the geoengineering is blocking the sun, changing the climate through tinkering, as they said, tinkering with the skies and the clouds and the ocean, and it's risky. And this solar geoengineering, there's several proposed technologies, none of them proven. You brighten the low clouds so that the sun reflects off the low clouds and goes back out to space. You thin the high clouds so you don't get the infrared coming back. It just gets released because the high clouds are part of the greenhouse gas. You put some stuff in space to bounce the sun back, kind of like mirrors, or you put aerosol scattering, dust, like volcanic dust, or stuff in the atmosphere to keep the sun, you cut back on the sun's rays. So there's a bunch of stuff that they'd like to try. And there's some skeptics, obviously, and there's some folks that say this is the way we're going to solve our problem. Removing it is another like we got lots of carbon dioxide, why don't we just take it out of the atmosphere? But it takes energy to take it out of the atmosphere. And so you're kind of a lose-win, or it's not a win-win. Iceland actually has a system run by geothermal that's taking carbon out of the atmosphere, but it's not nearly at a scale that's going to make any difference. But it's a start, it's an idea. And then there's carbon capture. The oil sands is promising carbon capture, so it's going to release its, reduce its emissions by capturing the carbon from the production of and the refinement of the oil sand tar, but it's not proven. One project was just canceled, but there's a lot of hope for this one. There's actually the Carbon Cure, which is a Halifax company, has created a system to actually inject carbon dioxide into concrete and cement. And it actually makes it stronger and absorbs carbon dioxide, where cement normally releases carbon dioxide in the curing process. So this is a Carbon Cure, which is a successful. Bill Gates and others are investing in this one. But the mitigation so far, although we have lots of hope for renewables, and renewables are finally going to pass coal in the world next year, we're slow. We're too slow at what we're doing. And while the public is aware of the problem because of the extreme weather, there's a lot of doubt and disinformation in the system where people are not ready globally to make the kind of tough decisions we have to make. And then the question is, how much do we put a price on it to change behavior? Or how much does the market change the behavior? And China can actually influence the global market. President Xi thinks he's going to solve the problem. They're doing actually more renewable energy in China than anywhere else in the world. So they've got a target of, which perhaps is realistic, 2060 net zero. But there's not enough public support. Big oil has been spending decades influencing politicians, funding political parties, and sowing doubt. All we need is a little bit of doubt that I don't want to spend a lot of money or change my life. And so since 2010, while the target was 45% reduction by 2030, we're actually going to be increased by 9% by 2030. It's better, but we're way off target, unfortunately. And the question I have is China really going to change things? Like the cars are cheap. You can buy $11,000 US electric vehicle, but we have lots of tariffs on them because of our free trade agreement and the auto pact with the USA. We're not welcoming the Chinese electric cars, but there are a lot of electric cars in China. And the battery storage, China's been growing their battery storage industry more than anyone. So China's kind of an interesting case study. So given that we're kind of slow, unfortunately, in the mitigation part, what are we going to do to adapt? Because we have to make our cities, our communities more resilient, our homes. So we have to be aware of it. We have to understand what our individual and our risks are in our communities and support that. Buildings have to be designed differently. Building codes and standards have to be changed. We have to invest in infrastructure, whether it be dams or dikes for flooding, bigger stormwater infrastructure to take the water away, cooling centers for the heat and like. We've got to change where we put our homes and how we build our homes, especially along the coastline or along the river banks and the like. And unfortunately, the most valuable homes are the ones in the most vulnerable areas. And the cities and the towns, they're benefiting from the value of those homes from a tax base. So there's no incentive for the municipalities to say, oh, don't build there, because that's their tax base. So the thing is kind of upside down. We need joint shared responsibility, all levels of government, as well as industry and us as property owners and residents. And The high-risk properties that are already there, we got to figure it out. We're not going to, tear them down. We have to understand what the real risk is, and are there ways of living with that risk? And there are ways of living with the risk, but somebody has to pay something. So the flood risk, the biggest challenge and the frustration I have in Nova Scotia, we're challenged with the coastal flood. Our rivers are small, they flood easily. And then there's flash flooding, where you get water where you wouldn't expect it otherwise, because of the rate of rainfall, and our stormwater infrastructure can't handle it. And as I said, the most expensive properties are often the most valuable ones. And then because of that, several communities, East Hants, Lunenburg, City of Halifax, I had to sign an NDA to look at our flood maps in the ones that were done in Halifax, because there's a reluctance. People don't want those flood maps to get out because it's going to impact their property value if they're in a floodplain. Or if it does come out, wait a minute now, buddy over there, he flooded last year and he's not in the floodplain. And I did, that floodplain map is wrong. And so you can imagine a public meeting on this stuff. And so the municipal officials are having trouble releasing the flood maps that exist or spending the money on it. But they're so vital to our decision making. We have to know our risk. Flood mapping is only one part of it. But Calgary, after the flood, they put in the 2013 flood, a whole system to understand the risk. The maps are out. Preparation to save your life, make your property more resilient. And so government, citizens, developers, so they've got an action plan to deal with that. But they were forced to, because believe me, the insurance industry wasn't very happy after 2013, because the MP for Calgary persuaded them to be paying out homes that really weren't covered for flooding. They say, oh yeah, it was a sewer backup. But it wasn't sewer backup. The whole river came over the thing. But and the MP was the prime minister at the time. Sydney, big flood in Sydney, and it's been a floodplain for a long time. And this is one where I told you I was working with the insurance industry. And I went to Prague. There's a company called Impact Forecasting that has mapped the whole country of Canada so they could sell flood insurance. And when the insurance company told me, hey, we're offering flood insurance now, I said, can I see the map? No, that's proprietary. You can't see our maps. And I said, well, how do I find out if my house is in a floodplain? I don't want to finish the basement. I don't want to put my grandkids sleeping in the basement if it's in a floodplain. She said, oh, apply for flood insurance. If you don't get it, you know you're in a floodplain. Anyways, so this company gave me some floodplain maps to show Sydney and Halifax, and I showed public safety. And they also have hazard maps to show what the likely velocity and depth, and whether it'll wash a car away or a house away or whatever. These risk maps are available. This is that area that flooded in Sydney. The map is bang on, and they have higher resolution maps available now. And I think those maps should be made public. And I am loud and clear to that. I was on national TV saying it, and every chance I get talking to any politician, these maps, and it's better for the federal government to put it out. Then there's none of this mucking around, property owners whining at them, because it's the federal government. It's not their pure jurisdiction. They're not going to have public meetings. But these maps have come out finally, the coastal risk maps that the province put out, but they're not really that detailed. And this is the Coastal Protection Non-Act. So you put the maps out and then you hope somebody's going to do something with it. And they are, to be fair, they are providing money to the municipalities and expertise to the municipalities to do things to make their floodplains more resilient. But there's no laws, there's no regulation around where to build and where not to build, about armoring coastline. And so that needs to change. And it has to be a province-wide or a country-wide approach, not a municipality. I mean, we have some expertise in Halifax, but there's no way Antigonish County, this is Antigonish County, there's no way they have the expertise to deal with this challenge. In fact, they can't even agree whether they're a city or a county. So there's expertise out in this province on managing dikes. That's a big part of the Annapolis Valley and up through the Tantramar Marsh, big part of our corridor. So, you know, to do it using nature-based systems. Mayor Savage is big on nature-based systems. This is a tweet Tim Bousquet put out the day after the Coastal Protection Non-Act came out. And the stakes were already in the ground in Lunenburg County for some beach development that's taking place. And I would never build there, but someone from Ontario would love it. They don't know they're going to get flooded. We have to be ready for more hurricanes and stronger hurricanes. The insurance industry has all kinds of advice, Intact and a group called Institute of Catastrophic Loss Reduction, on what to do with respect to backwater valves, sump pumps, minimize what's in your basement, manage the flow of water within your property. There's lots of things you can do, even if you're in a flood likely place, to make your home more resilient. Same with fires. There's all kinds of guidance from the insurance industry for homeowners. And your insurance company should be providing you with this information. And speaking of insurance, the insurance industry did a study, and they basically asked homeowners who are in a high-risk area of flooding, basically a 50% chance that their home is going to be flooded in the next 10 years. How much are you willing to pay for insurance? Because it's almost a sure thing in the life of your home is going to get flooded. And those homes are expensive homes. Only 50% were willing to pay about $4,000 a year for a home that's worth probably $500,000. People don't want to pay because they never paid before, and they want the government to bail them out. And so the insurance industry is working with the government to find a way to find a middle ground. So the insurance industry insures it, the homeowner pays more than they are used to paying, and the federal government backstops the insurance industry so that if there is a catastrophic flood, the insurance industry doesn't necessarily have to swallow it all. So that's in the works, actually. So there are some solutions. I am hopeful that our back is against the wall, that we will actually jump on the bandwagon. And maybe, I mean, Biden's doing a lot of work there in the States, but he's not getting any credit for it. Maybe China will turn things around. I don't know. But we're going to have to make some tough decisions. That's the fact. I'm not a proponent of geoengineering. I am a proponent of working together, talking about it, designing our infrastructure and using our land to be more resilient, having financial incentives and disincentives so that if you're in a floodplain, you can't build because you won't get a mortgage or you won't get insurance. And what we're doing today is talking about it. That's extremely important. And I'll just summarize by saying it's a simple concept of why we're getting warmer and more extremes. It's serious and getting more serious because the impacts are only accelerating. But we do have the information we need to make the changes. We just have to have the will to make those changes. Thanks to Scott Denning of Colorado State University, who came up with this concept of simple, serious, and solvable. There are some resources I'll leave here. The most, this is Climate Atlantic is here in Atlantic Canada. Catherine Hayhoe is a climate scientist in the States, but she's Canadian. Climate Central has a lot of resources. Some of my slides are from there. And Climate Connections, How We Thrive, is recently developed here in Nova Scotia. And they have a climate course that's starting in a couple of weeks. So howwethrive.org. I'll leave it at that and we'll have some questions. Yes. And speak loud. The microphones for you folks are right up there.
Thermal more incentivized as a heating solution?
My
And
opinion-
what portion of the planet could it apply to?
Well, geothermal, certainly Iceland is a good example of where geothermal is really the predominant source of heating, and I don't know electricity, but heating certainly. It's expensive, the system. You have to go deep in the ground. I know that,
But you only pay once. then
pardon
you
me?
You only pay once, then you never pay again?
presumably, that there's an unending source of heat and cooling in the ocean and in the ground. So geothermal is a really good solution, but to build it is expensive. But large parts of the city, I think some of the new Cogswell Exchange, geothermal using the sea. So that's probably going to be the biggest initial project, large scale project here in Nova Scotia, but it's a good question. Any other questions? Okay. Can you put the hurricane? Can you, the hurricane forecast in 2024 again? At the end, will do. So I'll put it back up again, or is?
Can you just describe it in words?
Well, I forget the exact numbers, but essentially we're going to have double the number of storms from normal, and 50% of those are going to be hurricanes, and 10% of them are going to be major hurricanes. So it's a busier year than normal. But it doesn't mean that they're going to hit us. There's all kinds of work being done which part of North America is most at risk. Believe me, who would have figured that Miami has not gotten hit by a hurricane since 1990? Hurricane Andrew, but Halifax has gotten 3, so go figure. Next question. Why are you concerned about nuclear? I've heard there are lots of recent improvements in technology. I'm not concerned about it personally, but there's a lot of public concern about nuclear. And it's largely because of 2 things. 1, it's expensive to build it in a way that it's safe. 2, somebody has to deal with the waste because it lasts for millions of years and you have to bury it somewhere. Saskatchewan has some geological ground to allow that to happen, and they're willing to put it because you mine a lot of the uranium in Saskatchewan. But nuclear, it's an expensive investment from a utility or from a government perspective. And it takes a long time to build because of the regulations. And not everybody's convinced that the risk is low, especially when things like Fukushima and Chernobyl have taken place. And so people always think of the worst case, but it's a proven technology. Ray, do you have any comment on that?
Yes, I see the benefits of nuclear power. It can be a cheap, reliable method, but say it's the regulation that has made it so expensive.
All right, thanks. Ray and I studied physics together. Yeah, yes.
Is there an argument against nuclear that, as you said, it's very expensive to build a nuclear and it takes a long time. And by the time they've built them, global warming will have wiped out.
So the latest conversation is on something called small modular reactors. So these are smaller nuclear systems, kind of, and they're hoping to generate kind of a can-do small modular reactor business here in Canada. It's not necessarily been a proven development yet that you can do it cheaply. The concept is there, and there is money being put in by the federal government for the research. That's where a lot of the hope is, that we'll be able to do it with small, less risky and cheaper initiatives. SMR, you'll see that term used, small modular reactors, I think it's called. Any? Bill has,
Jim,
yes,
Jim,
Bill.
as you know, the largest natural sink of carbon dioxide is the ocean.
Yes.
But the other carbon dioxide problem beyond temperature change is the acidification of the ocean.
Exactly.
So that is, you know, the twin problem of increasing CO2. And yet there are ways, geoengineering ways of pulling CO2 from the atmosphere into the ocean.
Yes.
And I know the arguments why that should not happen, but do you have any opinion as to why one would not try geoengineering by pulling CO2 from the atmosphere to its own natural sink, which is the ocean?
Well, I mean, I have several slides on ocean acidification that I did not include. And ocean acidification is basically the carbon and the calcium within living things in the ocean. There's a chemical process that forms carbonic acid. Phil would know more than I. I'm answering your question that Bill knows the answer to, but it's basically threatening the health of our ocean ecosystem. Corals are bleaching, and the loss of phytoplankton would have an enormous impact on our living ocean. And so the acidification of the ocean, that is happening from the absorption of carbon dioxide into the ocean, threatens, here in Atlantic Canada, it threatens our living ocean, and it's serious. Now, Bill, give me the real answer.
Well, you know, at Dalhousie Oceanography, there is a project
Yes.
that plans to line the ocean, alkaline. In other words, counteract the effect of acidity with alkaline, and in essence, line the ocean. Do you have any thoughts on that?
Well, I don't know enough about it, but I do know that the Ocean Frontier Institute is funding a lot of the research, and Anya Waite, who's the chair of the Ocean Frontier Institute, she just got an award, probably one of the world's experts in carbon sequestration in the ocean. And they've started one of the biggest large-scale tests by putting lime off of Bedford Tufts Cove to test the viability of this. So absolutely, if it works at the local scale, it's something we could do at a larger scale, but the ocean is big. We're going to take down the White Cliffs of Dover to save the ocean ecosystem. It's big. It's bigger than the atmosphere. Yes,
Dangers associated with storing carbon underground, and is there, at the same time, is carbon capture and storage?
so the storage of carbon underground, I don't see that there's any risk. They're storing it in theory, it's being stored in a geological situation that can cap it, so it doesn't release. Kind of where the oil came from. They put it back in the form of carbon dioxide. But I'm not sure the technology is there to do it at large scale and be guaranteed that it's not going to leak. The next thing you know, you get this massive release of carbon dioxide, you're back to square one. And it's expensive. And it takes a lot of energy to pump carbon dioxide deep into the ground. And what are you actually saving if you're using as much energy to pump it underground as you are saving in carbon dioxide? So you have to find green ways, fossil fuel-free ways of actually doing that work, like the folks in Iceland have done with the carbon capture from the actual air. Yeah, well, exactly. That's right. But Iceland's not going to save the world. But I admire the research that they're doing. And it's part of nothing like James Watt with the steam engine never imagined where he was going to go with this. So you start with stuff. And as I said, we're a pretty resilient species. We can figure this out. And there's a lot of smart people in this world. We will have a breakthrough, but breakthroughs are usually incremental until all of a sudden you look around and you say, wow, look what happened. And no way would James Watt have imagined the world that we live in now. Neither would Fourier when it came to the, his initial concepts on greenhouse gases and what it might do to the climate. Yes.
Is Spring Hill, Nova Scotia, employing geothermal or acquiring energy through geothermal methods by using the flooded coal mine?
I don't know. I do not know if they're doing it. I know they're putting up big solar farms up there in Spring Hill. I do not know if any large scale geothermal going on in whether it be Cape Breton Island or in Spring Hill. I know that Cape Breton University wanted to get some funding to do that kind of work. Certainly the windmills in Lingan were part of that, the start of that alternative approach to energy leadership that Annette Verschuren actually initiated when she was chairman of CBU. But I don't know. It'd be good, it'd be great to start thinking about that. Be interesting to see what happens in Cogswell Street, Cogswell, whatever it's called.
I think Purdy's work, when it was built,
Yes.
used sort of a geothermal approach to cooling.
The sea is wonderful because it's colder than the air in the summer and warmer than the air in the winter. Perfect. And so we're blessed with the sea. We can find ways of doing it inexpensively. It is a great answer in the coastal zone.
What can we do about our political systems
Yeah.
so that they're more responsive? The more we get educated about this, the more frustrated we get because our political systems don't seem to be appropriate. There was a journalist recently who measured, I guess we keep data on this, about the lobbying that goes on by the oil industry. Well, we do keep the statistics with the assumption that a journalist is going to tell us about this, and we're all going to what? What are we going to do once the journalist tells us about this?
Well, I mean, let's face it, politicians are renewable because in many ways, we're the ones who make the decision. That's why talking about it, I've been doing some work with the faith communities. We're in a church, and the faith communities need to get on board, especially for the young people, to get the young people back into the faith communities. And the Christian, the Muslim, the Jewish communities here in Halifax are working with Ecology Action Center to work together on this. Some of the things they're doing is doing energy audits of the churches to make them greener, putting EV charging stations within the parking lots, and then developing the conversation with the church leadership so that the moral responsibility of us is to talk about it, not only at home and in the bottom of the basement of the church, but also in the top of the church. And so talking about it will change and influence politics. But it's a project. and because we're short-term thinking and politicians are short-term thinking, to put a carbon tax or some other initiative that's going to benefit us in 2050, no one even cares. The price of gas went up 10 cents or 3 cents or something, and the whole world fell apart. And And it's the opposition that, and I'm not blaming either one. It doesn't matter who's in opposition, they're going to be pointing fingers. The democratic system is not necessarily the best designed system to make tough decisions. It's why China's maybe solving it for us through a market-based system when it comes to a point where goods and services depend on being generated by in a fossil fuel, there's a price on it, the carbon price, and then the cars in China are going to be selling more because it's cheaper for us to run, for the environment, and so the market can actually, as much as the market got into this mess, the market can get us out of this mess as well, if we think outside the box.
I think we'll draw it to a close. Jim, I want to thank you from the bottom of my heart. This was a wonderful talk. We've all got tons to think about. I'd also like to thank the women who provided the break for us. So thank you.
Thanks, Barbara. Certainly a pleasure.